we have Dr. Vishal Krishna. He is a faculty at IIIT Lucknow. His research interest includes wireless sensors, big data analytics, and IoT. Dr. Krishna has many publications in journals of repute to his credit. I am happy to have Dr. Krishna with us. Dr. Krishna, over to you.
So, thank you so much for the introduction, ma'am, and I hope we'll have a wonderful session today. So, I hope my screen is visible to the participants. I'm
Yes,
hoping
It
for
is
a
yes,
visible
response.
to
yes, it is.
Okay, okay, okay. So, what I'll do is I'll
There's a bit of
disable my
background
video for
sound
the.
that can be avoided. There's a little bit of background that can be avoided.
I think everyone else should mute their mic, and I think yeah, it is better now. So what I'll do is I'll disable my video for the initial half of the presentation. And in case you have any queries or questions, please wait for the session to end, and then I'll
सुनीता
enable.
न्यू स्टूडेंट्स का ना न्यू स्टूडेंट्स का मुझे एग्जामिनेशन लेना है आज 4:30 को तो
There's a
मैं
background
कैसे उनको
there.
इन्फॉर्म कैसे करूँ क्या करूँ
Please, I'll request all the participants, organizers, and whosoever are here helping us in conducting this, please mute your mic so that
Sir,
we
we will also take
okay.
care as soon as somebody
So
unmutes, we'll
okay,
mute
so let
the
us
mic.
start with yeah. Thank you so much, ma'am. So okay. So, good morning, everyone. I'm Dr. Vishal Krishna Singh, and today I'll be presenting a brief introduction of machine learning and specifically fairness in machine learning. We will discuss what fairness in machine learning is. Bias in machine learning. There are different names with which we can address this. So, fairness in machine learning or addressing the bias in machine learning. We shall briefly talk about the about the possibility and the ideas. The basically precisely the possible ways to achieve fairness in machine learning. So in the next hour or so, we shall cover the following topics, which as you can see here are mentioned in the outline of the presentation. So we shall start with an introduction to the machine learning framework, the fundamental concepts of the machine learning, the applications of the machine learning, the methods of the machine learning. We shall also discuss the machine learning algorithms with the real world examples. We shall also cover the concepts of fairness in machine learning with a brief introduction to the concept of bias in data. We shall cover algorithmic fairness and also the concepts of fair machine learning. As you can see on the screen over here, the introduction to machine learning is the introduction, the brief introduction about machine learning. What is machine learning? What are the different applications of machine learning? Now, the general description or a concise or a abstract summary of machine learning, all what we have discussed till here. And then finally, we shall see some practical examples also. As I was saying that we shall discuss the fairness in machine learning, we shall see what fairness actually is. We shall see how data can be biased and what is the concept of bias in the data. Then we shall discuss the concept of algorithmic fairness. Why is it important to have a fair algorithm and how these algorithms can create a problem if they are not fair? And if they are not fair, then what does this mean? This means that there is some discrimination involved. Now, what are the different types of discriminations involved? We shall also see that, and then finally we shall conclude with uh, what what is expected with a fair machine learning method or algorithm. We shall finally conclude this session with some of the challenges and the possible research opportunities for the researchers or whosoever is working in this domain. So this is the entire outline of the presentation which we are going to see today. So before we dwell into the details of fairness and all the related concepts, let us first try to understand the fundamental concepts and the meaning of the term machine learning. So So, the first and the foremost question over here is, what is machine learning? Now, to answer this question, the answer to this question can be easily understood from a very simple fact that which is quite evident as well, that it is when we start to write a program, if we talk in very general terms, then what we say is, what we can think is, or it is quite evident that it is very hard to write a program that can solve complex problems, right, of the human mind, right? For example, the problem of recognizing a face. And if we are supposed to write a computer program for that, I'm speaking generally, right? So if you are supposed to write a computer program to recognize a human face, to write this complex because we don't know the working of the human mind. We don't know how this recognition system works. We are unaware of that, and because of this reason, it is not possible for it is quite difficult for us to write a complex program which will be able to do this. So we don't know what program to write, because we don't know how our brain does it. So or let us say, even if we had a good idea about how to do it, the program might be so complicated that it will not be easier for us to understand the entire thing. So instead of writing a program by hand or by on a computer machine, what we do is we collect lot of examples that is specify the correct output for a given input. Now, this task is, you can get the picture of machine learning from this statement which I just said, that we collect lot of examples. We collect a lot of examples which are, okay, this is A, this is B, this is C, this is D, and similarly we go on collecting a lot of examples with the specification that these are the correct output when when A is the input, B is the output, when C is the input, D is the output. So the correct output for a given input is specified, and it is it is introduced to the machine. Now the same thing is what we do in a machine learning problems, or the concept of machine learning. So the concept is something similar to that. When I say what is machine learning, so a machine learning algorithm takes these examples. What I just said, we collect a lot of examples. So the machine learning algorithm, what it will do is, it will collect these examples and produce a program that does the job, whatever job you are interested. For example, the recognition of a face. Now, the program produced by the learning algorithm may look very different from a typical it may contain. But the thing is that if we do it right, the program works for new cases as well as the ones we trained it on, right? So we had already trained the program on certain set of input data, because the input and the correct output was specified, the program was well trained on it. So if everything goes right, because of this training, this program will be able to work on or give exactly accurate results on the unknown data also. So basically, all the things which I just said can be realized from this picture on the screen. You see that in a traditional programming scenario, you can provide the data and the program to the computer to obtain the desired output. However, as I just described, the machine learning scenario allows the computer to learn from the data samples to do the desired task on the testing sample. I hope they figure traditional programming and the machine learning programming, the concepts of these two, the traditional programming. What I was saying is this traditional programming and this machine learning programming. I hope the concept is clear from over here. This is what I was explaining. So as I just said, you provide the data, and the program to the computer to obtain the desired output. However, however, when we talk about the machine learning scenario, the data and the output is provided to the computer. The computer learns from this data and the output, from this data sample to do the desired task, and generates a program for doing the same task on generated inputs. जो नए data elements होंगे उनके लिए भी वो काम वो कर सकता है. So
Just
these,
just one point, Mr. Singh.
yeah.
Sometimes we are missing your voice
Oh,
for a little
okay.
while, and then you are coming back again. So
I,
I need to take care of that.
oh, I think this must be because of some network issue. I'm not sure why this is so, but okay. Okay, if the problem persists, please do let me know. I'll
Yeah, yeah,
try
sure.
to reconnect with different
Yeah,
network.
since beginning about twice.
So, okay, uh, let's hope that I'll try to reconnect with a different network if the problem persists. So,
Okay,
okay,
thanks. Thanks. Yeah, sure.
okay. So, so as I was saying, we were discussing the traditional programming and machine learning. What is the difference between the two? And the general concept was, see, all these definitions and all these concepts which I am trying to explain over here are in
Sir,
are
I'm sorry to interrupt actually, Vishal sir. This is Vikas. My point is, in the previous slide, you have mentioned that the data and the this output will be a input for the computer, and then the program will be generated. So are we going to cover this part as well in this session, that how the program will be generated based on the input of the data?
yeah. Just allow me to complete this entire
Sure.
session. See, the thing is, this every concept which I'm going to discuss over here is basically, if I go on explaining every concept in detail, that will be a bit of a tedious task to complete in 1 hour or so, right? So I have tried to cover most of the important topics. For instance, I'll try about talking about supervised learning, unsupervised learning, and how this training of the machine, these there are so many algorithms which are devised for machine learning methods. Okay, I'll see.
The
I'm not
point here
sure.
is, the point here is the audience is mix of some have the computer knowledge, some people
Yeah,
don't have that much of the mathematical knowledge. So it's a mixture of audience over here. I mean, the team is mixture of all these people. So try to make these things elaborated in such a manner so that it will be easy for us to understand. Actually, that is the only objective. Because
Yes, I'm aware of that, and this is that is what I was about to say. That I'm whatever I'm trying to explain over here, I'm explaining all these things in very simple terms. Although if we go deep in the concepts of machine learning and all these things, so these concepts might not be might not appear this simple. But yes, I'm trying to explain the concepts in a simpler terms, so that all the participants, who some of them might be aware of these concepts of machine learning, however some of these participants might not be aware of this. So I'm basically trying to lay a neutral ground for everyone.
thank you very much, sir. Thank you.
Okay.
Mr. Singh, can I ask a question?
Yeah, please.
You said that this machine learning is data and output are fed into the computer,
Yeah.
and then a program is created by the computer itself. So my question is that the same program is run on the computer to get the output?
Actually, when I say that when a input and when a data and output is provided to the computer, it is uh, basically we have a model or something. For instance, a training, let us say, a artificial neural network, or some training algorithm is there. We
Mhm.
feed the input and the output to the this model, or
Mhm.
let us say the ANN, right? Artificial neural network. And
Right.
based on this input, the when I say the data means the samples which are for which, let us say, I have your face as an input and your name as the output, right? The desired output. Okay, when
Correct.
we are talking about a face recognition algorithm. So
Right.
this ANN or this model, whatever is over here, this will take your face as an input and will map or will train itself to the output. Okay, these are the features, this is the output, and basically some of the features are identified by this model, and this model which we are talking about, the ANN or similar training algorithms, they
Mhm.
train themselves on this data. And once let us say there is someone's face, let us say my face, and the algorithm is not aware of what is the name for this face, then
Mhm.
the entire task is that based on the training data, the algorithm will be able to generate a output for the unclassified or for the unrecognized data. Now when I
It
say,
is saying that it is not recognized.
yeah.
Yeah.
So when I say it will generate a program, it is not as simple as that. It is see, as I said, this concept is very a very simple representation of what the thing is. When I say
Mhm.
program, it is not actually a program. It is basically, uh, once this training has been done, the model is now capable of accepting new inputs and giving a desired output.
Right.
The,
Right. Right. Right.
so
Right. Right.
this program is basically
Yeah.
the trained model,
This is
right?
the model actually.
Yeah,
So
this
with the help
yeah
of the data and the output, the computer will create a model
yeah
in themselves. Yes. Okay.
yeah.
Okay.
So,
Bas-
so in a layman language, if I talk about 2 plus 2 is 4, so if I give data as 2 plus 2 and output as 4, the program will identify whether the addition, subtraction, deletion, multiplication, what needs to be done. Am I right, sir?
See, okay,
No, no.
let me take a very simple example. I think this will clear the entire doubt.
Mm.
So, okay, when we go to a bank, right? So when we go to a bank for a loan, let us say I go to a bank for applying for a home loan, or a loan for taking a car, right? And once I
Right.
go to the bank, the bank makes a certain decision. I give my application, and the bank certainly decides, okay, uh, we cannot give you the loan. And why is it so? I'm not aware of the fact why they rejected my loan application, or I am not aware of the fact why they accepted my loan application. But if you see, there are certain factors involved in this, and try to understand these certain factors. Now these certain factors are, see, there are so many things. We'll talk about this in detail in the upcoming slides, but yes, let me explain this as simply as I can. Let us say there are two persons. Let us say there is me and one other person. Let us say his name is A. Now, when A goes to the bank checks what is the age of this person A. Let us say it is 25 years. What is the income of the what is the income of this person A? Let us say it is 1 lakh rupees per month. What is the expenditure of the this person A? And similarly, there are certain set of features which the bank sees. Now, when I say the bank sees, consider the bank as the training algorithm which I was talking about, right? So
Okay.
based on these set of inputs, the age, the income, the expenditure, and all these things, a certain conclusion is made. For instance, if the age is 25, okay, this is good. The income is 1 lakh rupees per month. This is good. The what is the expenditure? The expenditure is 50 lakh rupees per month. Oh my God, this is not great. So is the loan can be given? No, not. But instead, if this expenditure was not 50 lakh, it was, let us say, 75,000 per month. Okay, this seems fair. And then there are certain more questions. What is the CIBIL score or something, or there is some score associated with it. Okay, it is very good. Yes, loan can be given. Similarly, the algorithm trains itself on a certain number of data sets. For example, let us say 10,000 inputs, 20,000 inputs, 1 lakh inputs, and all these things.
Mm.
Based on this, the algorithm trains itself to decide, okay, a general parameters are set. Okay, if the age is below 50 years, the income is around 50, expenditure is this much, and the return is this, the CIBIL is this, and all these things are this, then the loan can be given. Else, the loan will be rejected. Now, this the algorithm has developed on its own based on the training data.
Right. Right.
The 10,000, 20,000, 1 lakh inputs which we were provided, that were given to the algorithm, and the correct output for the algorithm for that input was known to the algorithm, right? So
Right.
now, when the algorithm is aware of these 1 lakh inputs,
Mm.
then when I go for the loan, it is not that that the bank is biased towards me or the algorithm is biased towards me. I am just a simple one another data entry to the algorithm. When I go to the bank, I feed my information to that algorithm or the model. It simply considers what is the age, what is the income, what is the expenditure, and
Hello.
yeah,
Your voice
I
is
think
being
the
gone.
voice has gone.
Hello.
my
Your
voice.
voice is gone.
Yeah, sir.
Is it okay now?
Yeah. Better. Better.
I think there is some disturbance in between. Please, all of those who are asking questions, please let them ask questions. Everybody else, please keep your mics on mute, because if there is a interference in between, it will not be clear for any of us, right? So okay, so as I was saying, I am just another data to the model. Now, so this model, what it will do is it will see what is the age, what is the income, what is the expenditure, and all these things, and it will generate the output. Okay, bank loan can be granted. No, bank loan cannot be granted. But these are the two outputs which the algorithm is giving, and based on that, the bank decides. Okay, whosoever you are, it doesn't know who I am or who A is or who B is. It is not biased on the basis of the name or the position or the something. It is just working on the data. So this is what happens over here. This is what I was talking about.
Right.
Uh,
Right.
Sir, I'm sorry to interrupt here. Sir, earlier as well, when we do this kind of thing in Java programming,
Yeah,
so for
excuse,
us,
just a minute. What I'm saying is, see, I have a limited time over here, and there are so many concepts which are to be discussed. Now, if we go on discussing these concepts in such at such length, we I won't be able to finish all the topics. So
Sure, sir.
it's better. It's better that I'll try to summarize my topic by, let us say, 11:15, and then in the last 15
Sure,
minutes we can go on with the question answer session.
sure, sure, sure.
All right.
Thank you.
Right. Thank you very much. Thank you. Carry on.
Okay, okay, okay. And please do note the questions so that by the end of this session we can have a healthy discussion about the topics or the points whichever are not clear or something, right?
Right.
Sure, sir. Right. Thank you very
Okay,
much.
okay, okay. So as I was and see I was at that time when the discussion started, I was saying that the concepts which are being explained over here, or these things, I'm explaining them in a very simple terms. These things are not as simple as they are being shown over here. So this is because some of you might be aware of the concepts of machine learning and traditional programming and computers and Java programming, C programming, R, Python, and all those things. But in order to lay a neutral ground for all the participants, these concepts have been explained in a very, very simple terms. So that is why I think that is, if you were paying attention, the discussions which we were having right now were the just the proof of that whatever is written over here is not that simple when it comes to when we go deep into these topics, right? So these are for the fair understanding of all the participants. But yes, if you have the understanding of these concepts, you will definitely be able to grasp the upcoming topics which we are upcoming discussions which we are going to have. So as I was saying, so the entire discussion, or the this thing which we were discussing, so what you can say, is this a magic or something? No, obviously no, this is not a magic. This is the process of machine learning, and this, if you want to relate it, you can see, you can relate the entire thing with the process of a with a gardening process. You can see that the algorithms and the data are used to generate the desired output to meet the end user requirements. So the seeds are the algorithm, the nutrients are the data, because without data these seeds cannot grow, or these algorithms cannot grow. The gardener is the code, is the person who is writing the code. And finally, the plants which are the programs can be seen as the plants which grow in our garden. So when you feed the data to the algorithm by with a certain with in a curated manner, you will get a program which will be able to do certain kind of things, right? So now this okay, this example, okay, I don't think this example is required, but okay, I'll try to finish these examples so that I can cover all the topics quickly. So uh, an instance of a machine learning use is shown in the figure over here, where the task is to identify the number two from a given set, and obviously we need a training data and a testing data to develop an algorithm, and then we can obviously predict the figures which can be categorized as the number two. Obviously, the training and the testing of the algorithm decides the accuracy rate and the error rate. But we will come to that part of the problem a bit later. With the general idea of the machine learning scenario, you can easily visualize the applications of the technology in the real world. For instance, the web search, the computational biology, the finance, e-commerce, space exploration, robotics, and all these applications of these For instance, the example which I was discussing about the bank loan. So this is one of the very common example which we can see in our day to day life. Similarly, I'll talk about few more examples in the as we approach different topics regarding this. Now, apart from these applications and examples, if you there are some more examples which you can, once you dwell into these topics, you'll see that machine learning can be used for recognizing patterns. Now, machine learning can be used for generating patterns. Machine learning can be used for recognizing anomalies. I think someone's mic is unmuted now. Please mute your mic. Okay. So, machine learning is also used for stock prediction, market prediction, and all those things. Machine learning is also used for that. So if so all these things, all these examples, and all these applications of machine learning, you can say that the applications of machine learning are not limited to a specific domain, uh, but they are divided into a lot more. It is mostly applicable in each and every domain as we know of as of now, be it in the domain of computer science, be it in the domain of mathematics, be it a domain of management, or even the MBA students are using machine learning algorithms for different purposes, which are being used for their research analysis and research, because management students are dealing with data analytics and all those things. So data analytics is a core concept which is applicable for the machine learning algorithms. Now, uh, uh, with all said and done, all the machine learning algorithms basically have three components as shown on the screen over here: the representation, the evaluation, and the optimization. Now, the first is the representation. You have to try to understand this concept with the general idea of the represent. What is the general idea of representation of the data? So basically, the data correlation, the useful information in the data, the possibility of occurrence, etc., and all these concepts are some of the parameters which are frequently used by the algorithms for this component. How the data can be represented and how it can be shown, can be presented together. Now, as when I say the useful component of the data, I hope the concept of entropy and all these things are known to the participants. Similarly, when I say data correlation, I hope the concept of correlation is known to the participants. For instance, see what correlation is for those who are unaware. Let me try to give a brief note about correlation. For instance, correlation is what? Let us say five people are sitting in a room, and and we all are looking at a we are let us say we are experiencing the air from a air conditioner. Now we all are sitting at random places, and the space between us might not be the same, or it might be same. We are not really aware of that. But then again, two people who are sitting in close proximity will experience almost the same temperature from the air conditioner, right? Because they are sitting in close proximity. However, two people who are sitting with a significant space between them might have different experience of the air which is coming out from the air conditioner. So this is what correlation is. This is known as the spatial correlation. The the relation between two data values because of the space, or the point from a point of observation, or the point of origin of the data. So this is the spatial correlation. Similarly, we have a temporal correlation, but okay. So this is the concept of correlation. So when we talk about representation, now the representations can be done in so many ways. Now decision trees, set of rules or logic programs, instances, graphical models, neural networks, support vector machines, model and symbols. So there are so many ways in which representations can be done. As I was talking, decision. This is what I was discussing when we were talking about the bank example for the loan. For instance, consider this example of decision tree. There is a test. There are possible outputs. Whatever is the output, see, the question is, should I wait at this restaurant? You went to a restaurant and you are waiting for someone, or let us say you are over there and you are deciding whether should I wait or should I leave the restaurant and go to some other place. Now there are some questions related to that question, which tests which will help us answer this question. Now, the first one is patterns. So, are there any patterns? Then none. Then the output is false. If there are some, then true. If it is full, then what is the weight estimate? If the weight estimate is more than 60 minutes, let us say, then no, we should not wait. Then if the estimated time is between 30 minutes to 60 minutes, then okay, what are the alternates for this? But if the waiting time is between 10 to 30 minutes, then we have to decide, okay, are we hungry or not? If not, if we are not hungry, or if we are hungry. So if we are hungry, yes, yes, then what are the alternates? Is it raining? No, then okay, I should wait at this restaurant or not. So similarly, these are all every every answer to every test might result into might result into another set of tests. However, there are certain questions which can or certain set of tests which can definitely put our query to the end, and we shall be able to decide whether this can be done or this should not be done, whether the bank loan can be given or whether this bank loan cannot be given. So decision tree, this is what I was talking about initially. So this is one of the examples of data representation. Similarly, we have another example of a Bayesian network. Now Bayes theorem is there, so I'll not go deep into the Bayesian Bayes theorem, but I'll try to explain the concept of Bayes theorem and Bayesian networks with a very simple example. Consider the figure over here, or okay, let us forget this and let us look at a simple example. Okay, when we talk about Bayes theorem or Bayesian network, consider this, that we are talking about conditional probability, joint probability, and all these things. Now, conditional probability can be considered as what? The occurrence of one instance is dependent upon the happening of the other instance, conditioned on some other influence. For example, now these Bayesian networks are used to determine the probability of what is the probability of something to happen. So if you see over here, the basic task is to compute probability distribution for unknown variables given observed values of other variables. Given that certain thing is true, what is the possibility of some other event to happen? For instance, consider that there are two or three things that might happen or might not. There can be a burglary in the house, or there can be earthquake in the proximity. In both these cases, an alarm can go off, right? And if the alarm goes off, the neighbors can call the police, right? Or they cannot. But okay, these are the possible outcomes. But when we say okay, when there is an earthquake, given that an earthquake has happened, what is the probability of the alarm to go off? Or given the earthquake has happened, what is the probability of neighbor calls? Given a earthquake has happened, what is the probability of a radio report? Similarly, given the probability that a burglary is happening, what is the probability of the alarm to go off? Similarly, given the alarm is ringing, what is the probability of the neighbor calls, right? So these are some of the probability consideration which Bayesian networks deal with, and they come up with certain numbers, and based on this, it is decided what is the most possible, most probable outcome for a given that certain set of conditions are true. The same thing which I was saying for the bank example, that can be reflected over here. For instance, as I was saying, given that your age is less than 25, what is the probability of you returning the loan on a timely fashion? Given that my expenditure is this much amount, what is the probability of me returning the loan properly or in time? So these are all these cases can be dealt with these network in this case. So as I was saying, the first topic which we were discussing was the representation. Now the second component is the evaluation of these algorithms. The evaluation of these algorithms, the methods and the techniques can be done on several parameters. Now these parameters are accuracy, precision, recall, likelihood, posterior probability, margin, entropy, and all those things. For instance, the accuracy and the coverage curve here shows the performance of the evaluation parameter of a machine learning algorithm. On the y-axis, you can see that there is the classification accuracy is measured with respect to the coverage on the x-axis. Similarly, this is a triple trade-off which considers the bias variance trade-off. And finally, so these are all the evaluation parameters. For instance, if we are dealing with accuracy of an algorithm, you'll see obviously we need accurate algorithm, but how do we measure the accuracy of an algorithm? We need to have the true positives. We need to have the true negatives. We need to have the false positive. We need to have the false negatives. Once we have all these four, we can calculate the precision. We can calculate the recall. We can calculate all these things, and based on this, we can have the accuracy. So false positive, false negatives, all these things can be calculated based on the outcomes generated by these algorithms or by the methods which we were seeing in the previous examples. These are just some of the examples or how these accuracy can be measured or can is represented. For instance, in this example, there is this classification accuracy and this is coverage. As the coverage grows, as the coverage of the this, let us say I'm talking about some random algorithm, this shows that as the coverage grows, the accuracy, the classification accuracy falls or following a specific pattern. So this is some one of that example. So this was the second part. Okay, see, we were discussing this. If you have forgotten, we were discussing this representation. Then we had discussed the evaluation, and then now finally we'll see what optimization is. So the third component is the optimization. It is also an integral part of the machine learning algorithms. Now, this optimization can be achieved in different ways. Now, in different ways. For example, the greedy search, the gradient descent, linear programming, and all these are examples of optimizing different methods in different ways. So without going in detail, I'll quickly come back to the types of machine learning which we are going to discuss over here. So basically, we have three types of basically these machine learning types can be classified into these three categories. So और भी बहुत कुछ है इसमें. There are over the years the machine learning types have been some more machine learning types have been introduced, but the fundamental or the basic concepts remain the same. Supervised, unsupervised, reinforcement, these three are the fundamental types in which machine learning can be classified. Now, supervised learning, when we talk about supervised learning, you can see that the name indicates that there is a supervisor present as a teacher. So basically, supervised learning is learning in which we train the machine using a data which is well labeled. That means some data is already tagged with the correct answer, right? This is what was happening in case of the decision tree, right? So after that, the machine is provided with a set of examples, or let us say a set of new data, so that the supervised learning algorithm analyzes this training and analyzes the training data or whatever data was which was provided initially, and produces a correct output from a labeled data, right? So this is what was happening in the decision tree example also. Then we have if you want to have another example, we can yes, I was supposed to discuss one more example, but considering the amount of time we have, I'll skip that example, and I'll quickly jump to the unsupervised learning part. So, okay, before jumping to the unsupervised learning, let me quickly say that the supervised learning, as it was written over here, the supervised learning can be roughly classified into two categories: classification and regression or prediction. So, classification problem is when the output variable is a category such as red, blue, yes, no, disease, no disease, for example, such as this. And then we have regression. So regression problem is when the output variable is a real value, such as the weight or the rupees or something similar to that. So supervised learning, basically, supervised learning deals or learns with the label data, which implies that some data is already tagged with the correct answer. So so the entire concept of supervised learning is based on this. Now, if you want to talk about the advantages of supervised learning, there are many advantages. For instance, the supervised learning allows collecting the data and produce the data output from previous experiences. It allows optimization of the performance of the existing algorithms based on the previous experiences of the algorithm. So the advantages are many. The second thing is the unsupervised learning. So unsupervised learning is basically the training of the machine using information that is neither classified nor labeled, right? And which, because of this, the this allows the algorithm to act on the information without any guidance, right? So here the task of the machine is to group unsorted information according to the similarities, patterns, or the differences without any prior training of the data. To understand the unsupervised learning algorithm, let us try to understand this with a very simple example of a clustering. Now, what clustering is, I hope all of you are familiar with the concept of clustering, but for those who are not, consider a group of people sitting in a classroom or in a market area, and you don't have any prior information, or you don't have any prior knowledge or training about how to group them or how to classify them in a simple category. Then what you can simply say You can cluster them. You can cluster them. Please, okay. So you can simply say that all the people who are wearing red T-shirt, they can be grouped together. All the people who are wearing yellow T-shirt, they can be grouped together. All the people who are wearing blue T-shirt, they can be grouped together. Now let us. I said T-shirt, right? Now let us say I'm assuming that all the people are wearing T-shirts. Let us say someone is wearing a kurta, or let us say someone is wearing a shirt, for instance, or someone is wearing a black T-shirt, which has not been classified, or there is only one person who is wearing a black T-shirt. In that case, that person or that data point will be considered as an anomaly, and that is a totally different thing. Anomaly detection is a separate entity, and it is a separate topic if you go on understanding it. But yes, that is an anomaly, and that has to be considered. So I hope the concept of unsupervised learning is now clear. So when we talk about the third component is the reinforcement learning. Now, the name of this technique is a great hint to what this technique is. As the name indicates, reinforcement learning. So obviously, it is about taking suitable action to maximize the reward in a particular situation, right? If you take if you praise someone for doing a job brilliantly, then obviously that acts as a reinforcement to the person, right? So it is employed by this technique is employed by various softwares and machines to find the best possible behavior or the path it should take, the machine to take in a specific situation. Now, how it differs from a supervised learning is that in supervised learning, the training data has the answer key with it so that the model is trained and the correct answer itself. Whereas in the reinforcement learning, there is no answer, but the reinforcement agent decides what to do to perform the given task, right? In the absence of the training data set, it is bound to learn from its experience. Now, consider you can see the figure on the screen. Consider this. Consider that we have an agent and a reward with many hurdles in between. Right now, this robot agent or the agent is supposed to find the best possible path to reach the reward. Now, this is the reward, right? To have a clear picture of the problem, you can see the you can refer the screen on your computers. This agent or this robot is supposed to reach to this reward diamond, and these are the hurdles. These fire kind of things are shown as the hurdles. Now the robot, this robot learns by trying all the possible paths and then choosing the path which gives the with the least hurdle, right? It will try different paths, different possible path, and it will choose once it has reached this path, it will realize, okay, this is the path with the minimum trouble and the maximum reward. So each right step will give the robot a reward, and each wrong step will subtract the reward of the robot. So this is the kind of learning which is meant by reinforcement learning. Now the total reward in this kind of learning, the total reward will be calculated when it reaches the final reward, which is the diamond at this in this case. So if the robot goes over here and then realizes, okay, there is no path over here, comes back over here. The robot goes over here and goes over here, then it sees that, okay, this is not possible. Then goes over here, it is not possible. Similarly, it starts from at this point and goes directly over here. Okay, it is not possible. So only then the robot realizes, okay, I have to go here. From here, I can go over here, and then from over here, I can go over here. Now from here, I cannot go at this point. I cannot go towards this point. Then the only way forward is this point, right? From here again, it will discuss, or it will try and test hit and trial method, that okay, I shall go to this, I shall go to this, okay, no. So similarly, based on all the possible paths and the straight path directly towards the diamond, it will realize that okay, if I had taken this path directly, I would have got the entire diamond, but instead I did take a wrong decision at this point and at that point, and hence only half the value of the diamond is given to me. And this is what reinforcement learning is about. So the main point to remember in the reinforcement learning are regarding the input and output, and the training and the learning and the reward. So basically, the input should be an initial state from which the model will start. The output will be, there are many possible outputs, that as there are variety of solutions to a particular problem. Then there is training. Training is based on the input. The model will return to a state, and return a state, and the user will decide to reward or punish the model based on the output. And the model keeps on learning. The best solution is decided based on the maximum reward. So if you want to summarize reinforcement learning, you can summarize the reinforcement learning in these 5 points. One of the apart from all these discussions, I wanted to discuss this because this example is the best example which you can think of when you think of machine learning and association analysis, and the use of algorithms and machines for in our day-to-day life. So the this is probably the last example I'll be discussing. After that, we shall go to the biased and fairness concept. So association analysis or the market basket analysis is a very popular concept when you go to when you go to a shopping mall, or these supermarkets such as Big Bazaar, Spencer, and all these similar market stores. You see that. Have you seen bread and diaper to be placed together? No, because there is this market basket analysis. Now, this market basket analysis is based on the number of the type of items which are purchased together, and the number of times these items are purchased together. So see, if you see that there are millions and millions of transactions being done in these supermarkets every day. Now consider the first transaction where bread and milk are bought together. Then consider the second transaction in which bread, diaper, beer, and Coke are purchased together. Similarly, the third transaction in which bread, diaper,
Your
beer,
voice
and
is
Coke
gone.
are purchased together. Okay.
We couldn't hear you for the last few seconds.
Okay. Am I audible now?
Yes, better.
Okay. So I hope.
You
Okay.
are in the first
Okay.
transaction. You are in the
Okay.
first transaction. Better,
Okay.
yeah.
Okay. Okay. So when you go to these supermarkets or some these things, you'll see that let us consider the first transaction where the bread and the milk are purchased together. Similarly, the bread, diaper, beer, and eggs are purchased in the second transaction. Similarly, in the third transaction, milk, diaper, beer, and Coke are purchased together. Now you see that similarly there are so many transactions. Let us say there are 10,000 transactions in this manner, and then what you'll realize is that what the idea is to place these items together. See, the entire objective is I'm talking about a supermarket, for instance, Big Bazaar, Spencer, or similar supermarkets. Now, what are the items which should be placed together? Because this is the human psyche we are talking about. If I am into that supermarket and I have purchased the bread, there is a high also purchase the milk. But if I have purchased bread, is there a high probability that I will purchase beer as well? No. If I have purchased bread, there is a high probability that I will purchase eggs. It might be the case. If I have purchased bread, is there a high probability that I will purchase a baby diaper as well? No, that is highly unlikely. So, this is what the entire analysis is about. What are the associations? See, learning associations means these two items, what is the association between them? So, this is what association analysis is all about. Two items, what is the probability of two items being purchased together? When you go to these supermarkets, you'll realize that when you see the columns associated with bread, you'll see milk items to be placed just once these kind of studies have revealed that. I'm just taking this for example. It is not the case that it will be always true, but for instance, I'm saying that let us say we conducted this study and we see that, okay, see, consider these five transactions. In the first transaction, bread and milk are purchased together. In the fourth transaction, bread and milk are purchased together. In the fifth transaction, bread and milk are purchased together. So out of these five transactions, in three transactions, bread and milk are purchased together. So obviously, this there is a high probability that whenever bread is purchased, milk will also be purchased. However, uh, once you see that what is the probability of milk and diaper to be purchased, so you see that milk, whenever milk is purchased, in the first transaction no diaper, in the second transaction no milk, in the first transaction milk is there, diaper is there, milk is there in the fourth and diaper is there in the fourth transaction, yes. Similarly, okay, milk and diaper also have high probability to be purchased together. So based on this, these items can are placed in these supermarket aisles so that once the customer is there, uh, making this easier for the customers to their purchase, and this has certainly helped the supermarkets to increase their sales as well. So this is one of the popular examples which is used in data mining, in machine learning, and all these concepts. Now, considering the limited time, I'll not go in detail with this, but I'll quickly jump to fairness in machine learning. So, I hope the concept of fairness you have a basic idea what fairness in machine learning is. Fairness in machine learning is nothing but the idea behind fairness in machine learning is that the algorithm should not be biased, should not be partial towards anyone. For instance, we are humans, right? I might be biased towards a particular gender, a particular race, a particular tribe, or a particular category, or a particular class of people, because I'm a human being. Obviously, whenever I'm sitting on a decision making platform, because of my human tendency, that I might favor a specific group. Because of this, the final outcome or the final result of this decision making process might suffer. But when we talk about algorithms, this is not expected from the algorithms, because the algorithms are machines, right? And they are designed to make a accurate and fair assumption or predictions based on the data in hand, not on the grounds of what the person is, what the name of the person is, what the gender of the person is, what is the category of the person, and all. See, these are all the possible scenarios in which humans can make these biasness, or they can be unfair in these terms, but the algorithms cannot be. They do not have this leverage, and they should not be given this leverage of having a biased approach or having a biased decision towards anyone. So, uh, if I say the what is fairness in machine learning, then the first question to ask is that why we care about fairness. So the main motivation is that it is highly related to our own benefits. Now the machine learning systems have an as we were discussing just now, that machine learning systems have been an inseparable part of our daily lives. They are becoming even more widely used in the near future, and more fields are coming together to integrate AI and machine learning in every possible way. Now, in nowadays, we are making use of algorithms for making movie recommendations, what products to buy, what stocks to buy, what are the different high stake decisions are also focused on, are also dependent upon these algorithms. Even in certain places, hiring decisions are also taken by the by certain algorithms. Now, if that is why, if all these important decisions are taken by these algorithms, then obviously, like people, algorithms are also vulnerable to biases, and when the decision is unfair. But if decision making, then and if you want to define fairness in
Your
terms
voice
of,
is your voice is gone.
okay, is it audible now? I think
Yes.
there is network issue over here.
Yes.
Okay.
Yes.
So as I was saying, that if we want to talk about, if we want to define fairness, or fairness in terms of decision making, because see, fairness in machine learning cannot be defined in a simple terms, because there are so many ways this fairness can be dealt with and can be defined with. So I'm just trying to explain the concept of fairness in terms of decision making, right? So in when we talk about decision making and fairness, so if we want to define fairness in terms of decision making, then we can simply say whatever we have seen till now. What we can simply, if we want to put it in simple words, we can say that the absence of any favoritism towards any individual or a group based on their inherent or acquired characteristics, right? So if we say this, so the algorithm has to make fair decision without considering their characteristics, or characteristics of the person or people, which might be inherited by them, or which they might have acquired during their life. So thus, what we can say is that an unfair algorithm is one whose decisions are skewed towards a particular group of people, right? So it is quite obvious that that artificial intelligence is good, but also it can be used incorrectly. So as we have already seen, machine learning heavily relies on data. So the data provide and that data is provided by the human being. And if the data is highly biased, we can definitely say the algorithm will be biased. So we'll have to make sure that these algorithms, or there is no bias in the data which is being fed to the machine, right? So the important question is that why bias is introduced into the data. And to answer the answer to that question is that data especially in the terms of big data, is in most of the cases is heterogeneous. Now it is generated by subgroups with their own characteristics and behaviors. So because of this heterogeneity in the data, some bias.
Your voice is going away.
Oh.
Yeah,
Okay.
better
So
now.
okay, so because of this heterogeneity in the data, this heterogeneity in the data introduces bias in the data. Now, I have tried to present the bias in the data, the effect of bias in the data in this figure over here. So I've taken this example of a nutrition study, which measured how the outcome, that is the body mass index, changes as a function of the daily pasta calorie intakes. Now, this is an example I have taken from a book. So this is not this figure is not mine. This data is not mine. I've just taken this figure from a book. I'll cited them at the end of this presentation. But yes, this representation is, as I was saying, that this representation is about a nutrition study which measured how the outcome, or the body mass index is the outcome over here, changes as a function of daily pasta calorie intake. Now the same is shown over here. You can see the solid red lines over here shows a positive relation in the population between these variables. Consider this figure for now. However, this was not at this point. At this point, the researchers were unaware that the study population was heterogeneous. Now, when I say heterogeneous, that means that they were composed of smaller groups that had different fitness level. Fitness level. When I say fitness level, that means people who did not exercise, people who with normal activity levels, and athletes, and they all were merged in the same population. Now, when the data is disaggregated by the fitness level, the trends within each subgroup are negative, that is the dashed green lines, leading to the conclusion that the increased pasta consumption is in fact is associated with a lower BMI. Now, therefore, you can see that because of this uh, heterogeneous data, considering the heterogeneous data, the algorithm could not predict the right cause of the body mass index. So this is one of the examples of bias in data. So apart from this, I'll try to quickly summarize. There are few things which I needed to discuss, but okay. So there are these biases can be of different categories. Historical bias can be there, representation bias can be there, measurement bias can be there, aggregation bias can be there, and all these biases are affecting these systems in one way or the other. Now, apart from this, the when we talk about algorithmic fairness or algorithmic bias or algorithmic uh, this, then the methods that target biases in the algorithms fall under three categories, that is pre-processing, in-processing, and post-processing. In pre-processing, the pre-processing techniques try to transform the data so that the underlying discrimination is removed before the data is actually processed. In processing, during the processing of the data, and post processing is performed after the training by accessing a holdout set which was not involved during the training of the model. So these are the three methods in which generally
Your
these
voice is
kinds of
gone.
can you hear
Hello. So your voice is gone.
me now?
No, sir.
Okay.
We are not able to hear you, Mr. Singh.
trying to manage it.
Can you hear me now?
Yes, sir.
Okay.
Yes, yes.
I'm sorry, but I have rechecked my internet connection and everything is fine at the end. But okay, let's say, let's see. So as I was saying, there can be different types of discrimination which can be introduced into the which can be introduced in these algorithms. Direct discrimination, indirect discrimination, and so many things. So without I'm sticking to my timeline. So to conclude, I will say that okay, I was supposed to see. Okay, so to conclude, I will say that while there have been many definitions and approaches to fairness in the literature, the study in this area is just is this is a great research domain which any one of us or all those who are practicing machine learning for or who are dealing with machine learning for research uses or they are
Say,
teaching
can you
research.
show us the challenges slide, the challenges and opportunities slide?
Yeah. So basically, this is what I was summarizing the challenges and opportunities. So the thing is that fairness in machine learning is a very important concept and which we all can use
Mhm.
to take, because see, the machine learning algorithms methods, these are, yes, they are important, and they we are actively looking for classification methods, we are actively looking for optimizing the certain classifier or certain model or certain method.
Mm.
But the fairness in machine learning, this has this part is, it remains fairly untouched. When you see, when you do a random Google search and you see you search for fairness in machine learning and you see research papers over there, you'll see a lot of research papers which are coming in the past, which have come in the past 5 or 6 years, and they are very good publications. They are published in very good journals, in IEEE transactions, in ACM transactions, and all those. And they are just based on what? They are just based on the idea that the biasness in the algorithm, the biasness in the data should not be there, and how to cope up with this and how to overcome from this drawbacks of the algorithm. The entire research in this domain is focused on this. And
Mm.
personally, I would say that fairness algorithm bias still this still holds a number of research opportunities. There are several remaining challenges to be addressed in the fairness. For instance, synthesizing a definition of fairness. Even the fairness definition is not accurate, because the fairness can be approached in so many different ways. So several definitions of what would continue fairness from a machine learning perspectives have been proposed. Now these definitions cover a wide range of use cases, and the result are somewhat disparate in the in their view of fairness. Because of this, it is nearly impossible to understand how one fairness solution would fare under a different definition. The same, because fairness is a single word, but when we talk about fairness in terms of decision making, the definition is different. When we talk about fairness in some other concept, the definition is different. So a common definition which can be incorporated for everything, that because this is a very huge field. So synthesizing a common definition is definitely an active research problem. Now another important issue is the search for fairness, right?
Mm.
So given a definition of fairness, it should be possible to identify instances of this unfairness in a particular data set. But unfairness may require more consideration due to the variety of definitions and the possible and the possible biases, the type of biases which I was discussing over here. For instance, this was the Okay, I have not included that in the slide, but yes, there are so many type of biases which can be present in the data, and hence these biases need to be overcome. So that will be all from my side for today's session, and I sincerely hope that I had more time to dwell more on these topics, because these topics are uh, uh, they need more time to discuss in detail. But yes, uh, I hope the session was useful to most of the participants. That will be all from my side. Thank you so much for listening. I'm open for questions now. Please go ahead.
Uh, See, with respect to the fairness and the removal of the bias on the data
Yes.
and the algorithm, is there any regulatory body which is being thought out, or is there anybody who is actually looking at the algorithms which are being employed by various organizations in the commercial world?
I'm not very sure about this, but right right now I'm not very sure about any regulatory body or something. But just for the sake of giving an answer to this, I'm sharing this, that I'm working on a project with some of my partners in United Kingdom and over there.
Mhm.
They have a standard over there that we have to make sure that we have taken all the possible measures for the algorithm to be unfair, fair, and the methods which we are taking for recruiting the people, even if we are using an algorithm for doing it, even if we are doing a human person to doing this, we have to make sure that those standards are followed. Now, what are those standards? For instance, in case of an algorithm, uh, we have to there are certain guidelines which were given to us, that we were dealing with human data, so it was identified to us that these are the features which should be considered. Apart from these features, you may consider some more features, but these are the features which are necessary to be incorporated. For instance, if we are taking 100 people of 100 data of 100 people, then it should definitely be 50 male and 50 females. Similarly, if we are taking data of 50 white people, then
Mhm.
it should have data of 50 black people as well. So
Right.
similar kind of guidelines were there. But as you asked, as far as any regulatory body, I'm not very sure about that.
So there are standards and guidelines, right?
Yeah, basically there are standards and guidelines, and it is basically we who are developing these algorithms, and it is basically the human beings who are developing these methods for these machine learning methods. So this ultimately comes to all, let us to consider all these things to consider by us, because see, if you are working on a method, and if just for the sake of publication, if you say that, okay, you take all the sorted data and you give it to an algorithm, the algorithm will give you certain output. Now, if you don't publish the this word that the data which you have used is sorted, your algorithm will certainly show that your accuracy level is 99.9%, right? Now you have proved this in your research paper that this data is you have not mentioned that the data which you used was had this feature, but you have somehow got the result 99.9, and you have published the paper and you are very happy with it. But finally, after 2 or 3 years or 5 years, someone might come and ask why, what is the kind of data set you have used, or is it a sorted data set or unsorted data set? What is the number of inputs? What is the number of outputs? Because in a research paper we can hide so many things. We can
Right.
publish so many things, but then ultimately it is the human beings which need to, who are working for the greater good. They should be aware that hiding these facts would, they might get a publication out of that, but
Mhm.
it will, this work won't be helpful for the greater use, because they cannot be justified
Thank
when
you.
they come.
Thank you.
Yeah.
Thank you.
Vishal sir,
Any other question?
ma'am, may I ask one question?
Yeah, yeah,
I mean,
please.
Vishal sir, I am a IT professional, worked in Java development actually for quite a long time, and I still have a small doubt. I mean, it's a basic doubt for machine learning. Like
Yeah.
in the earlier times as well, when we were not having this machine learning in place. I mean, we were not much aware about the machine learning. In 10 years back, we do the development in Java, and we insert the programs in, or we can say that those are algorithms which we did the logic or whatever you say, that we document or do in the coding part, right? So why, if the same thing, like you gave an example of banking, where a person comes and if check whether he's eligible because of some eligibility criteria, then that can also be done in the basic Java codes. Then why is the requirement of machine learning nowadays? I am still not able to identify that answer.
See, let us be very clear about this. Uh, consider that we are living, right?
Your voice.
And
Yeah.
okay, consider that we are living in 1970s, and the amount of data which we have with us is, for a bank, let us say, we don't have internet nowadays in 1970s, right? We don't have sorry, internet. We don't have so many people coming to the bank. We don't have internet. We don't have computers to process the data. We have simply 10 people and 50 customers. You can easily deal with this, right? But as the technology has grown, you can see that the amount of data is so much, so much, that if you write a simple computer program, that will be able to do it. But what is the computation cost? What is the time? What will be the complexity of the algorithm? What will be the time which the algorithm will take to run, execute, and generate a output for that. Let us say you go for a movie. See, the recommender systems, the all these things are totally dependent upon the type of data and the amount of data. You see, machine learning and these computer programs have always been there. The only difference which now we have is the amount of data which we are having. You see, big data analytics is nothing but use of machine learning for analyzing this huge amount of data. So what happens is that since the size of the data has grown so much, that normal algorithms or the codes which you or me or all of us were writing 10 years back, is they that code might still work for that data, but it will take, let us say, 2 days to reflect the output. So is it acceptable to us? No, it is not. We want everything on the top of our fingerprint, or sorry, fingertip. So the amount of data and the time required by these algorithms to process this data is an important concern, and this is why the this machine learning, artificial intelligence, big data analytics, and all these things have gained momentum in the past decade, because of the size of the data and the need of fast processing of data.
Mhm. Right, sir. I got your point. Got your point. Thank you.
I hope Vishal sir has answered to all the queries. In case anyone has any question, you can ask. Otherwise, we will wind up the session. I think all the queries are over. Thank you, sir. Machine learning in itself is a very broad area, and it is actually difficult to explain everything in such a small time. But you have given a nice introduction to subject. I hope the participants have gained a brief idea about what machine learning is and what are its different types. Thanks once again.
Yeah,
Thank you so
absolutely
much,
a
ma'am.
brilliant session. Learned quite a lot about machine learning and have become really interested about it.
Great, great.
Very
So
much.
that is
Thank
actually the purpose of these
you. Yeah,
kind of
thank you very
sessions.
much. It was so simply dealt with, and you have brought us people like us who does not have too much of computer knowledge very near to understanding what machine learning is. Thank you very much.
Thank you so much.
Okay, Vishal sir, thank you very much. Um,
Thank you for hosting me and thank you for giving me this opportunity. And thank you, participants, for the patient audience. And sorry for the inconvenience caused during this session. I hope we interact some other day. And
right, sir.
hopefully,
Right, sir. We'll
thank you.
try to have one more session with you with the IT professionals.
Yes, sure. Sure.
Okay. Thanks a lot.
Okay, thank you.
Thank you very much, sir. Thank you, Ranjana ma'am.
So, participants, this session is over. Let's take a break. We'll meet again at 12 o'clock for the next session.
So, ma'am, will this be on the same link or it will be a different link?
It will be a different link. It will be provided to you
Oh,
within 15 minutes, right?
sure.
Okay.
Okay.